So till now, whatever motion we have studied the motion of single particle. Okay, so we studied linear motion, we studied circular motion, we studied something about vibrational motion also. But whatever we studied till now, it is motion of a single particle, right? We never considered the dimension, the shape and size of the bodies. Okay, so in this chapter, the system of particles and rotational motion, we'll talk about the rigid body motion. Okay, so what's the difference between motion of single particle and a rigid body? So for a single particle, what kind of motion can it perform? So whatever we have studied till now, right? It can perform linear motion, then circular motion, okay? Vibrational motion we can say, all right? And a motion which is combination of these three, right? Then if we think about a rigid body, okay, what do you mean by rigid body? So this is an approximation, okay? What kind of approximation? So for a body whose shape and size cannot be changed, so when you exert some external force, what will happen? It will purely result in change in motion of body, and the shape and size of body will not change. Such kind of body is known as rigid body. Okay, so because it's difficult to consider the real effects of the force on body, that is the change in shape and size, so we start with this approximation. Okay, so the rigid body is a body whose shape and size cannot be changed, right? So what kind of motion can this body have? Of course, it can move in a straight line. So for an example, let's suppose I throw this pen. Okay, so it can move in a straight line, right? Then it can move like in parabolic path. Okay, we studied the projectile motion, so it can move like that, right? It can also rotate like this. Okay, so there's various kind of motions it can have. Okay, so these are simple motions. So for an example, so for rigid body, it can have a linear motion. Okay, then it can have rotational motion. Okay, projectile motion we can say, and then it can have a motion which is combination of these motions. Okay, linear and rotational. So for an example, if I throw this pen, okay, so it won't go straight. If I throw it, oh sorry, I threw it, it won't move in a parabolic path like this. Okay, it will perform this kind of motion. So it is combination of, we can say, parabolic motion and rotational motion, right? So it is some kind of combination of parabolic and rotational motion. Okay, so these are the types of motion a rigid body can have. Okay, so while a rigid body performs this kind of motion, for an example, let's consider a rigid body. Let's talk about a block only. So when this body moves in a straight line, let's suppose it moves in a straight line, so all the particles within this body will move in a straight line. Okay, so let's suppose v is the velocity of this body. It means that velocity of all the particles within this body is v only. Okay, can it be possible that some of the particles are moving with more velocity and some of the particles are moving with less velocity? If this is a rigid body, so is it possible that some of the particles of this body are moving with more velocity and some of them are moving with less velocity? Let's suppose this block is made up of n number of particles like this. Okay, so out of those particles, let's suppose half of the particle are moving with velocity 10 meters per second. The remaining half of the particle are moving with 5 meters per second. So after 1 second, what will happen? So these particles over here, okay, they will cover a distance of 5 meters, 5 meter. And these particles will cover a distance of what? 10 meters. The body will break, no? Right? So it's not possible that some of the particles will have more velocity and some of them will have less velocity if it's a rigid body. Okay, if it is just a system of particles, if it is a gas, then it's possible, right? So if it happens that some of the particles have more velocity, some of them have less velocity, then the body will get distorted. Okay, so it's no longer a rigid body. So for linear motion, the velocity of all particles will be equal. So if it is accelerating, then acceleration of all particles will be equal. Okay, so V is equal for all particles. Acceleration also will be equal for all particles. Now let's suppose we have this disk. Okay, let's suppose we have this disk, and there would be some center of this disk. Okay, so center of top surface we can say, and there will be some center of bottom surface. So let's draw a straight line passing through those two centers. Okay, center of top surface and center of bottom surface, and let's call this line an axis. Okay, axis of rotation. So now this disk is rotated about this axis. So what will happen? All the particles within this disk will perform circular motion, right? The particle which is here, it will perform circular motion. Okay, it will move in this circle, right? Then particle over here, okay, let me use different color. Particle over here, it will move in some, sorry, it will move in this circle. Okay, so now will the velocity of this particle, let's call it first particle whose mass is m1, and velocity of this second particle whose mass is suppose m2, will it be equal? Now in this case this body is rotating, right? Now all the particles within this body should rotate through same angle in same amount of time, right? They should rotate with same angle in same amount of time. So for an example, let's suppose some of the particles rotate with 90 degrees. I'm sorry. Ravindran is saying that it will not be equal. Okay. So think about it. So let's suppose this disk is rotating. Okay. So suppose some of the particles rotate by an angle 30 degrees and some of the particles rotate with 40 degrees. Okay. So will this body remain the same? It won't remain, right? The intermediate distance, not intermediate, the distance between particles will change, right? If some particles rotate 30 degree and some particles rotate through 40 degrees, then the distance between particles will change, the shape of the body will change, right? So the angular velocity for all particles will be equal. So all particles will rotate by same angle through same angle in same amount of time. Okay, so for rotational motion, which quantity will be equal? Angular velocity, angular velocity of all particles will be equal. Okay, that is omega is equal, omega bar we can say. Okay, and then what can be different? So linear velocity will be different. Okay, linear velocity will be different because linear velocity. So let's think of this particle, this particle. So what will be linear velocity of this particle? Angular velocity multiplied by this distance, this much radius. For this particle, it will be angular velocity multiplied by this much radius. So the radii of two particles are different. Okay. So for first particle, it's small. For the second particle, it's large. And we know that V is equal to omega times R. Okay. R into omega. So omega is equal. If R is different, that means V will be different. So speed of particles can be different, right? But what will be equal for all of them? The angular velocity must be equal. Got it? Yes, no? So now see, when this body rotates, we have seen that particles within this body will perform which kind of motion? They will perform circular motion. Okay, they will perform circular motion. Okay, so points of body, we can say they will perform circular motion. But there are some points within this body, they will perform purely rotational motion. Which are those points? So if you think about center, okay, consider that top surface. So center of that top surface, it will just rotate, right? Okay, whereas this particle, it will perform circular motion. So particle over here, it will just rotate, right? Its motion will be rotational motion. Okay, it is true for center of top surface, center of bottom surface, and all the particles which are joining those two centers. Okay, so all the particles on this axis, okay, so this axis passes through this body, right? So all the particles on that line which are part of the body, those particles will perform purely rotational motion. Okay, other particles, all other particles will perform circular motion, right? So all the particles on the axis perform which motion? Purely rotational motion. Okay. So when we say the body is rotating, what are the points within that body which are actually rotating? The points on the axis only, right? So then if we think about this pen, so if I throw this pen, okay, in air, it will perform projectile motion, right? But it won't, I mean, let's suppose I throw the pen like this, okay, the pen won't go like this, okay, all the particles won't perform projectile motion. There will be only one particle which will perform projectile motion, and all other particles, for all other particles, their motion will be combination of projectile motion and circular motion, because this pen will rotate also like this. Okay, so which is that particle which performs purely projectile motion? So that particle is known as the center of mass. Okay, so we'll discuss about it. Okay, so that particle is known as what? Center of mass, right? So that center of mass, if we think about this motion, rotational motion, okay, then that center of mass, it will lie on this axis. Okay, so what is center of mass? It is the point at which whole mass of the body is supposed to be concentrated. All right, so we'll understand what this means. Okay, so it's the point at which whole mass of the body is supposed to be concentrated. So this is a hypothetical concept actually. Okay, but it has got some meaning. So which is that point? So we can guess it. So for an example, if I throw this pen in air, what kind of motion will it perform? Let's suppose this is the pen. So it's thrown in air, and it is thrown in air. So it will move like this. It will move along this path. So if you join the trajectory trajectory of the spin, it would be something like this. Okay, so there will be only one point of the spin which will perform purely projectile motion. Okay, it will perform what? Purely projectile motion. That point is the center of mass, right? That point is the center of mass. So, which you can say will be the midpoint of this plane if the plane is symmetrical. Okay, so let's understand. Let's see what is the technical definition of the center of mass. So, let's talk about one-dimensional case. So, how do we define the center of mass? So, let's suppose we have this axis. Okay, we have this axis, and let's suppose this point is the origin. Okay, and there is some mass, let's call it m1 at the origin, and there is some other mass m2 which is at some distance from the origin on this x-axis only. Let's call this axis x-axis. Okay, so now how do we define the center of mass of these two particles? So the center of mass will have only one coordinate because we are considering only one coordinate, only one axis, right? So the x coordinate of the center of mass is given by m1 x1 plus m2 x2 divided by m1 plus m2. Okay, so we have only two particles, m1 and m2, right? So what is the x coordinate of this first particle? It is 0. Okay, x coordinate for this particle is 0. What is x coordinate for the second particle? It is suppose x2. It is x2. Okay, then what will be the x coordinate of center of mass? So it is given by this formula, m1 x1 plus m2 x2 divided by m1 plus m2. Okay, so this is equal to 0 plus m2 x2 divided by m1 plus m2 if first particle lies on the origin, right? If the first particle lies on the origin. Okay, so this is how we find out the center of mass. You got this? Yes, no, the formula. For an example, let's suppose the first particle. Okay, so x1, let's consider that the masses of the two particles. So m1 is equal to 2 kg, m2 is equal to 3 kg. Okay, x1 is equal to 2 and x2 is equal to 4. So what will be the center of mass of this system? So x coordinate of center of mass will be equal to what? m1 x1, that is 2 times 2, plus m2 x2, that is 3 times 4, divided by m1 plus m2. So 2 plus 3 is 5. So that is how much? It's 4 plus 4 times 3 is 12. That is 16. 16 divided by 5. It will be what? 3.2. Okay, 3.2. So if this is meter, it will be in meters. If this is centimeter, it will be in centimeters. Right? So this is how we find out the center of mass. If the particles are located at various locations in space, then how do we define the center of mass? Okay, so for that we can draw three axes. So now we will have three coordinates x, y, z. Okay, so this is x coordinate, this is y, and this is z. X, y, z, and we have particles here. So let's suppose this is first particle, its mass is m1, right? And this is its position vector. Okay, this is its position vector r1 bar. Okay, then there is some other particle, let's talk about two particles only for now. So this is the position vector of second particle R2 bar. Its mass is m2. Okay. So now we need three coordinates. Okay. So x1, y1, z1, x1, y1, z1 are the coordinates for first particle, and x2, y2, z2 are suppose the coordinates for second particle. Then what can we do? We can find out the coordinates of center of mass. So center of mass will have three coordinates. Center of mass will have three coordinates. So x coordinate will find like this. X coordinate of center of mass is m1 x1 plus m2 x2 divided by m1 plus m2. Similarly, we find y coordinate. Y coordinate of center of mass is m1 y1 plus m2 y2 divided by m1 plus m2. And the z coordinate we can find by this formula m1 z1 plus m2 z2 divided by, and if we want to find out the position vector of center of mass, how do we find? By the similar formula. Okay, so position vector of center of mass can be found RCM bar is equal to what? M1 R1 bar plus M2 R2 bar divided by M1 plus M2. This is how we'll find out the position vector for the center of mass of two particles. We have defined the center of mass as it is the point at which the whole mass of the body is supposed to be concentrated. We'll see what's the meaning of this statement. So now if we have n number of particles, so we can extend this definition to n particles, right? So for n particles, we can extend this definition of center of mass. So we can say it is m1 r1 bar plus m2 r2 bar plus so on and so forth up to plus mn rn bar divided by m1 plus m2 plus so on and so forth up to mn for n particles. Okay, and we can write it in symbolic form using the summation symbol. So let's suppose its summation of I goes from 1 to n because we have n particles. So in numerator we'll have mi ri bar, and in denominator we have mi. Okay, so this is the position vector of the center of mass, right? Center of mass of n particles. Okay, so once again I will just write down the mathematical definition of center of mass. So RCM bar is equal to M1 R1 bar plus M2 R2 bar plus so on and so forth up to plus Mn Rn bar divided by M1 plus M2 plus so on and so forth up to plus up to Mn. Okay, so in denominator I have sum of, let's suppose we have a body and these are all the particles within the body. Okay, these are, so let's suppose we have this body and there are n number of particles in the body. Okay, so this body is composed of n number of particles, and m1 m2 m3 so on and so forth up to mn are the masses of particles within this body. So with respect to some origin, the position vector of first particle is r1 bar, position vector of second particle is r2 bar, position vector of nth particle is Rn bar. Then this is how we can find out the center of mass of the body. Okay, so this is the position vector of the center of mass, right? So in denominator, what do we have? M1 plus M2 plus M3, so on and so forth up to Mn. So if we sum up the masses of all particles within the body, what do we get? We get mass of the body, right? We get mass of the body. Yes, no? Yes or no? If we sum up the masses of all the particles within the body, if we add up their masses, then what do we get? We get mass of the body, right? So in denominator, what do we have? It's mass of the body. Okay. So now, if I take derivative of this thing with respect to time, if I take derivative of this formula with respect to time and move the mass towards left, what do I get? So I will write m multiplied by derivative of r bar cm. Cm is center of mass. So till now this is just a definition. Okay. So center of mass is the point which is defined by this formula. This is how we calculate it. Okay. And now what I'm doing is I'm moving this mass towards left, or you can say I'm multiplying and dividing by mass. Okay. Sorry, I'm multiplying both sides of the equation by mass. So m on the right hand side will get cancelled out. Okay. So what do you get? So now I'm taking derivative with respect to time. So on right hand side I will have m1 multiplied by derivative of r1 bar with respect to time plus m2 times derivative of r2 bar with respect to time plus so on and so forth up to plus mn times derivative of rn bar with respect to time. So this is equal to, so what is derivative of r1 with respect to time? So r1 bar is position vector of first particle, and if you take its derivative with respect to time, you will get velocity of the first particle, right? So you have mass of first particle multiplied by velocity of first particle plus mass of second particle multiplied by velocity of second particle plus so on and so forth up to plus mass of nth particle multiplied by velocity of nth particle. And what is mass times velocity? It's the moment, right? It's the momentum. Okay. So you are taking mass of first particle multiplied by velocity of first particle. You get momentum of first particle plus momentum of second particle. Okay. Momentum of second particle P2 bar plus so on and so forth to plus momentum of nth particle. So if you add up momenta of all particles within the body, okay, momentum of first particle plus momentum of second particle plus momentum of nth particle, you should get what? Mass of the body multiplied by velocity of body, right? That is momentum of body. But what are you getting is mass of the body times velocity of what? So it is derivative of position vector of center of mass with respect to time, right? So it is velocity of this point. Okay, it is velocity of this point, which we are defining like this. Okay, so it is mass of body multiplied by velocity of this point, which we are calling as center of mass. So if you add what? The momentum of all particles within body, that is mass of a particle times its velocity plus mass of second particle times its velocity, you should get mass of the body multiplied by velocity of body. But what are you getting is mass of the body times velocity of this particle. Okay, and that's why we can say what? The mass of this body is concentrated at that point. Okay, I said particle. It's not a particle, it's that point which we are defining using this formula. You got it? Why is it called center of mass? Because if we study motion of just this particle, it's equivalent to studying motion of the body. Okay, because if you add mass of first particle times velocity of first particle plus mass of second particle, mass times velocity of all particle, you should get mass of the body times velocity of body, right? But what are you getting? Mass of the body times velocity of this point. That means, okay, in a way, that total mass of the body is concentrated at that point. Okay, we can think as if the total mass of body is concentrated at that point. So this will get even more evident. We just have to take one more derivative. Okay, so we just have to take one more derivative to see how. So now what do we have? So we have mass of the body multiplied by the velocity of center of mass, and it's equal to mass of first particle times velocity of first particle plus mass of second particle times velocity of second particle, so on and so forth up to plus mass of nth particle times velocity of nth particle. Now you take one more derivative. So what do you get? So on left hand side you are getting mass times the derivative of velocity of center of mass. This is mass of the body times derivative of velocity of center of mass. Okay, and on right hand side, so this is a rigid body, so mass of all the particles within the body will not change. Okay, masses are constant, so it is just derivative of velocity, right? So it is dv1 by dt plus m2 times dv2 by dt plus so on and so forth up to plus mn times dvn by dt. Okay, so then what is this? What is dv by dt? Derivative of velocity with respect to time, right? So it is acceleration m1 into acceleration of first particle plus m2 times acceleration of second particle plus so on and so forth up to plus mn times acceleration of the nth particle. Okay, so what is mass times acceleration? It is the force. It is the force, right? So this is force acting on first particle plus force acting on second particle plus so on and so forth up to plus force acting on the nth particle. So this is, if you add up the forces acting on all particles within the body, you should get what? Force is equal to what? Mass times acceleration. But you are getting mass of the body times acceleration of which thing, which particle, or which point? You are getting acceleration of center of mass, right? So motion of which point will be governed by the external force, the total force. The motion of this point, which we call the center of mass, will be governed by the external force. Okay, see on right hand side, what do you get? You get F1 bar plus F2 bar, that is sum of all forces acting on all points of the body. Okay, so it will be the total external force acting on the body. Okay, and I will explain why I'm calling it's the external force only. Okay, but for now it is the total external force acting on the body. So total external force acting on body is mass of the body multiplied by acceleration of, it should be like this, right? Mass of the body multiplied by acceleration of body. But it is mass of body times acceleration of which point of that body, or it can be a point of the body, or it can be outside body also. Okay, but the true thing is it is found using this formula. Okay, what we know is it is found using this formula, right? So it is mass of body times acceleration of center of mass. Okay, and that's why we can say what? Once again, that the total mass of the body is concentrated at the center of mass. It is supposed to be concentrated at at center of mass. Okay, got it? The motion of which point of the body, or that point can be outside body too. So motion of which point is governed by the external force? Motion of the center of mass is governed by the external force. Is it clear? Yes, no? So why I am saying it's the external force? Let me explain this. Okay. So force acting on first particle can be due to the force acting on first particle can be because of other particle of the body, okay, or it can be an external force, right? So I can say it is F1 internal, the sum of F1 internal plus F1 external. Okay, similarly, force acting on second particle is F2 internal plus F2 external, and same thing for all the particles. Okay, Fn internal plus Fn force acting on nth particle due to some external thing. Okay, so now sum of all internal forces will be equal to 0. And why is this? It's because of Newton's third law of motion. Okay, to every action there is equal and opposite reaction. That means if we think of this body, so suppose this, okay, this particle exerts force on this particle. It can be any force. It can be the direct force, the impact force between the bodies. It can be gravitational force, whatever force. Okay, but if you think over the body, so let's suppose this particle exerts a force on this particle. So what will happen? So now this is first particle, this is second particle. Force on first particle due to second particle is F12. Force on second particle due to the first particle is F21. And these forces are equal and opposite. So they will cancel out, right? So similarly, you can think of all particles within the body. So all the internal forces due to particles within the body onto each other, they will get cancelled out. And what will remain is the external force only. So if you add up the forces on all particles, all the internal forces will get cancelled out. This is the consequence of Newton's third law of motion. And what will remain there is the total external force only. Okay, so you got this. So all internal forces get cancelled out, meaning what? If you sum it over the body, okay, all internal forces sum over body is 0. Okay. So resultant of all internal forces, you can say resultant of all internal forces summed over body is 0. Okay. So if you sum up forces on all particles, then the sum of all internal forces is equal to 0. So what will remain? Total external force which is acting on body. Okay. Okay. So this thing must be clear, that the external force F external, the total external force acting on body is equal to mass of the body times acceleration of center of mass. So if no external force acts on the body, what does it mean? The acceleration of center of mass will be equal to what? 0. Okay. So if external force acting on the body is equal to 0, then acceleration of center of mass is 0. Okay, and this is very important point. Okay, this is very important point, right? Oh, I'm sorry. All right, this is an important point. Okay, so is it clear? So that means if center of mass was at rest, it will remain at rest. If it was moving with a constant velocity, it will keep on moving with that velocity. If the net external force acting on the body was is zero. Okay, this is a crucial point, and there have been a lot of questions based upon this point. Okay, so let's see some questions. Okay, let's see some questions. This is from NEET 2020. Two particles of mass 5 kg and 10 kg respectively are attached to two ends of a rigid rod of length 1 meter with negligible mass. The center of mass of the system from the 5 kg particle is nearly at distance of. This is very straightforward question. There are two particles. Okay, so use our formula XCM. First particle has mass 5 kg. Okay, let me write it. M1x1 plus M2x2 divided by M1 plus M2. And if you are asked, okay, if you are asked what is the center of mass from the first point, then x1 becomes what? It becomes 0. Then directly you don't have to write this also. It is M2x2 divided by M1 plus M. Okay, so here it's the same case. It is 5 times 0. Okay, because you are asked center of mass from 5 kg mass. So 5 times 0 plus M2 is 10 kg times x2. So rod is of length 1 meters. Okay, so position of M1 is 0. Position of second particle, which is at other end, will be what? It is 1 meter, right? So it is 10 times 1 divided by, it is 5 plus 10. M1 is 5, M2 is 10. So this is 15. So 10 divided by 15 is how much? 2 by 3. 2 by 3 is how much? 0.66. 0. Recurrent 66, right? Or you can say 0.67 meters. Okay, that is in centimeters, 67 centimeters. So this is the answer. Let's see next one. Three masses are placed on x-axis. 300 gram. Oh, sorry. Three masses are placed on x-axis. 300 gram at origin, 500 gram at 40 centimeter, and 400 gram at x equal to 70 centimeters. The distance of center of mass from origin is, again, similar and straightforward question. Okay, so XCM is M1x1 plus M2x2 plus whatever number of particles are there, M3x3 divided by M1 plus M2 plus M3, and it's equal to, so for first one it's 0 because it is at the origin. Second one, mass is 500 gram multiplied by 40 centimeters, plus third one, the mass is 400 grams, right? 400 grams at 70 centimeters, and divided by, we have 300 plus 500 plus 400. We could drop the zeros, right? Because they will just get cancelled out. Okay, so it is 5 times 40. How much? 200 plus 70 times 4. 280. Okay, 280. divided by in denominator we have 300 plus 500, and I'm just neglecting the zeros. Okay, so it is 3 plus 5 plus 4. So it is 5 plus 3 is 8 plus 4. How much? 12. So it is 480 divided by 12. Tell me. Okay, good. Option A. 40 centimeters is the answer, right? Two bodies of mass 1 kg and 3 kg have position vectors. These are position vectors respectively. The center of mass of the system has a position vector. This is straightforward. Okay. So we have discussed the position vector of center of mass. It is what? Sum of position vectors. I mean, it's m1 r1 bar plus m2 r2 bar divided by m plus m2. Right? How much is m1? It's 1. 1 times position vector of first particle. I cap plus 2j cap plus k cap plus 3 times the position vector of second particle. So it is minus 3i cap minus 2j cap plus k cap divided by m1 plus m2 is 1 plus 3, it's 4. Okay, so now 1 I cap, this is minus 3 times 3. Okay, so minus 9 plus 1. How much? Minus 8. Okay, so minus 8 I cap plus 2, and this is minus 6. Okay, 3 times minus 2, minus 6. So it's minus 4. So minus 4 j cap, and it is 1, and 3 times 1 is 3. 3 plus 1, 4. 4 k cap divided by 4. So that is minus 2, minus 1, 1. Okay, minus 2 I cap minus j cap is k cap, right? So option A is the answer. This is simple. Consider a system of two particles having masses m1 and m2. If the particle of mass m1 is pushed towards the center of mass of, of particles through a distance d, by what distance will be the particle of mass m2 move so as to keep the center of mass of particles at the original position? So this is a simple question. See, question is, we have system of two particles. Okay, we have system of two particles. First particle is moved by distance d. By what particle should you move second? By what distance should you move the second particle? Okay, so we have these two particles. First one is m, second is m2, and they will have some center of mass, right? So first one is moved by distance d. By what distance should you move the other one such that their center of mass does not change? This is the question. Okay, so you can say that, okay, its center of mass is m1 x1 plus m2 x2 divided by m1 plus m2, right? And it is equal to, so first one is moved by distance d, right? So we can say it is now the position of first one will be what? So it will be x1 plus d, right? It will be x1 plus d. So it is m1 x1 plus d plus, now suppose we move second one by distance, whatever distance, m2 x2 plus, let's call it this distance as x. We have to figure out this, divided by m1 plus m2. Now if you multiply this, so m1 x1 m2 x2 divided by m1 plus m2, it will get cancelled out on both sides, right? It will get cancelled out. So what remains is m1 times d plus m2 times x, okay, divided by m1 plus m2 will be equal to 0. And if you move that m1 plus m2 on left hand side, okay, it will be anything multiplied by 0 is 0, so that will be 0. Again, voice is breaking. Oh, so then we'll have to stop then. Anyways, we'll see the problems tomorrow. And remaining problems we'll see tomorrow. It's the internet issue, my internet issue. Shall we complete this problem? This is uh, okay. This is almost complete, right? Let's complete this one. So now you can move this m2x on the other side. What do you get? So m1 times d will equal to minus of m2 times x. That means if you move, okay, m1 like this, then m2 you will have to move in the opposite direction, right? In the opposite direction, okay. So and x will be equal to what? So x will be equal to m1 upon m2 times d, okay, without the sign, okay. So what's the answer? The answer is m1 by m2 times d. This is the answer. Option B is the answer. Oh, shall I repeat this once again? Okay. See, what I was saying is, see, two particles are there, okay, and the center of mass of two particles is this. This is the center of mass of two particles, right? So then, first particle is moved by distance d. First particle is moved by distance d. Now, by what distance you should move the second particle such that the center of mass remains same? This was the question. So, you move second particle by distance x. Let's suppose we are moving it by distance x. So, what happens? Now, the new coordinates of first and second particles will be what? For first particle, it will be x1 plus d. For second particle, it will be x2 plus x. And that x we have to find out. Okay. So, then multiply this because center of mass is same. So, I have equated this thing. Okay. So, m1 x1 plus m2 x2 divided by m1 plus m2. This was original center of mass. Now the center of mass becomes what? m1, the coordinate becomes x1 plus d, okay, for first particle. For second particle it is x2 plus d, x2 plus x, okay, and x is we have to find, okay. So then this m1 plus m2 gets cancelled out. If you multiply this out, what will happen? So m1 x1 and m2 x2, it will also get cancelled out, okay, right? So that's why you can write m1 times x1, sorry, m1 times d plus m2 times x is equal to 0. And then you can find out x, right?